A very good morning, everyone. Welcome you all to day three of our FDP on Advanced AI Tools. Today we have with us our speaker, Swati, who is HOD of CSE and Director Quality IQAC at Gopalan College of Engineering and Management. Dr. Swati has immense academic experience of more than 15 years, and she also has industry experience of over 5 years. She has over 19 publications, including conferences, international journals, and she has published more than over 13 patents so far. She has also received various appreciations and awards. She has registered her own startup called EduCast, which is registered under MSME in 2022. She has also got received many uh, fundings from consulting agencies, and she is part of several invited talks and workshops. She's also received second rank in her MTech and has been Inspire Faculty Fellow from Infosys in the year 2017. We welcome you, ma'am. We are very happy to have you on the second day. I request our speaker to take over the session for the next 1 hour.
Morning, everyone. Today I'll be presenting about explainable AI tools, and also I'll show you a few literature survey tools used mainly for research oriented. So this is the agenda of my presentation. So I'll just start with the introduction to explainable AI. What is the need of explainable AI? And then what are the different tools used under this explainable AI? And few hands-on I'll be showing with respect to Lime, Sharp, and Sapash. So these are the tools we'll be having under explainable AI. So under literature review tools also I'll be showing you few demo. So coming to explainable AI. So we all know that machine learning models, whatever we have used, it is operated as black boxes because internal workings are not easily interpretable. So whatever the machine learning models will be developing, so all these are considered as a black box because we don't know what exactly internal things are happening. And the calculation behind these models are also very complex. And even whatever the features we are providing during the training, based on that only output is generated. So it's everyone knows that it is very difficult to determine which features contribute to the model's accuracy and which features are not giving correct accuracy. So it's difficult to interpret because whatever training we are giving, based on that only we are getting the result. But which feature is contributing more, which feature is contributing less, even we don't know and we are not aware why it is more and why it is less. So all these lack of interpretability issues is mainly led into the introduction of this explainable AI. Because in order to make the machine learning models more transparent and understandable to the humans, this explainable AI concept comes into picture. So that is why the starting of this need of this explainable AI came into existence, because we all know that machine learning models are like treated as black boxes. The internal thing, what is happening exactly till date, no one is familiar, and even we can't say like why it is happening like that. But using this explainable AI, we can easily predict how are the internal things happening for any real-time scenario. Now, this is the basic idea behind this explainable AI. So as I told you, you can see here, the machine learning models are treated as a black boxes because we have confusion with respect to why did you do that and why that accuracy is not coming, and then where we have succeeded and where we got a failure, and how can I correct my error. So all that some extent we can do, but not maximum. But in the case of explainable AI, the thing is we'll come to know like where exactly the model fails and where exactly if I'm including which feature my model accuracy will be improved. All that we can come to know and we can take necessary steps. And if you're seeing the right side of this one block diagram, here if you're seeing in the standard machine learning model, what exactly is happening is we'll be taking that data as input and we'll generalize the predictions and without even providing the insight of how these predictions were made. So the lack of transparency can result in generalization errors in the case of standard machine learning model and which are not easily interpretable. But in the case of interpretable machine learning model, we have used an additional step that where model predictions are analyzed for interpretability. So the use of this is it allows human how the model arrived at the decision and thereby we can refine the model. So the advantage of this explainable AI is at every step we'll come to know where exactly the model internal thing, what is happening with the model and where exactly the model failed, all that we'll come to know. So the interpretability is good with respect to explainable AI compared to the normal machine learning models. So there is a set of tools and frameworks to help you understand and interpret predictions made by our machine learning models. So it allows human users to comprehend and trust the result and output created by machine learning algorithms. So it's used to describe an AI model, its expected impact and potential biases. So mainly the need of this explainable AI is in order to interpret the result correctly. So which our standard machine learning model cannot do. That is the main use of these explainable AI models. The name itself, you can see like explain AI. So the more the outcome you are seeing, the more explanation you will get. So in-depth analysis of that model, you can be able to do using this explainable AI tools. So these are the various tools that are available with this explainable AI. So all the tools are categorized into two types. One is transparent method and other one is post-hoc method. So what is this transparent method is? All these are like basic machine learning algorithms, whatever we have used. So these are inherently interpretable because the model themselves are designed to be understandable by the humans. So all these algorithms are easily interpretable. And coming to post-hoc methods, so these techniques mainly when we'll apply is after a model has been trained to make its predictions more interpretable. So once we train the model, in order to make the predictions more interpretable, we'll be using these post-hoc methods. So in post-hoc methods, we have again two types, model agnostic and model specific. Model specific means with respect to our requirement, we'll be choosing this. Model agnostic means this is like if you want to do more in-depth analysis after training your model, you can go for this model agnostic tools. So these are the various tools we have: Sharp, Lime, Scatter, Ellis, Sapash, and Dalex. So these are the various tools we have under this explainable AI. So if you want to do more analysis, once you are training the model, you can go for this or any of the tool. Okay. So I'll show you now this out of this three tools I've taken, that is Lime, Sharp, and Sapash. How we can use these tools once after training our model. So coming to the first one, the first tool we have under explainable AI is Lime. So LIME stands for Local Interpretable Model Agnostic Explanations. So this is mainly used for checking in-depth analysis of your model after training. So this is a library, it's an explanation technique applied to machine learning classification or regression predictions in order to explain and interpret local prediction or a single observation. So by using this library, you can answer which features in your data influence the specific decision the most. So the summary I can say like this is powerful explainable AI library, which can be used either for classification problems or you can use for regression problems. But the thing is you can use entire model prediction also or single observation you want to elaborate more on that, that also you can do with this. So example, you can see here, I have taken. This is mainly for finding whether the model is giving me all these predictions. So if the person is having sneeze, weight, headache, no fatigue, and depending on the age, all these features. So it is categorizing like flu is there or not. So after this, once the predictions is done, if I want to apply Lyme for this, so what this Lyme tool will do is, among all these predictions, for flu, which predictions are most important, it will categorize. So if I'm seeing here sneeze, weight, headache, no fatigue, age, it will categorize like sneeze and headache are main features that are needed for the most occurrences of flu. So it will highlight that these are the two important features. So once these features exist, there is a chance of getting flu, and then it will give the predictions. So based on that, we can make decisions. So whether what are the features needed in order to predict whether flu is there or not. So this is the concept behind this Lyme tool. So what I mean to say is, so when we are training our model using any of the machine learning algorithm, it will give you a set of predictions. But in that set of predictions, if you want to see which are the most occurrences among all that, if you want to select that, you can use this Lyme tool. And if you want to do in-depth analysis of any of the prediction, then also you can use this Lyme tool. So this is one example, simple example I have given here. So for predicting the flu. And one more example, if you're seeing this down, there are two diagrams here. One is like this wolf, and one more is empty, down some image is there. If I'm uploading this image, there is a chance like if I want to, this diagram is basically to classify whether based on these images, it is for dog or wolf. But sometimes what will happen is our normal machine learning models, it will see the background, and where are this shape is there like this, it will give the incorrect predictions like wolf. But if I'm using the same thing with Lyme, what it will do is it eliminate all the background, and wherever the required features are there, only that it will consider and give the predictions. So that also will be done using this Lyme tool. And the next one we have is SHARP. So this SHARP is nothing but shapely additive explanations. So this is also a powerful explainable AI tool. So what is the advantage of using this tool is, you'll be getting all the visualization in one shot using this tool. So no need of again like calling one by one function and writing like MATLAB, all that. So Matplotlib using that, and you have to write, and then only your visualization plot will come. No need of doing any of the thing. So at one place only, at one shot only, you want to see all the visualizations with respect to your model. And based on the visualization, if you want to do any in-depth analysis, you can go for this SHARP tool. So this is also an explainable AI tool. So if you're seeing here, here I have the model, and the second picture I have inside the model, each different values are there, 0.4, minus 0.3, like that. So positive correlation, negative correlation. So in depth inside so many diagrams I can draw within one model only in one shot. So using this SHARP tool. And next we have this one more tool. I'll first complete the theoretical part, then I'll show you the hands-on for all this. So the next tool we have is Sepash. So the Sepash, this is also explainable AI tool compared to Lyme and SHARP. So this is, I can say, like little bit advanced, because as soon as you're executing this will be generated, web app will be generated. It's like a dashboard. So normally if you are using the Tableau and all, how the visualization charts will come, same thing you can generate using this Sepash tool. So when you're executing your model and when you're getting the prediction results, so whatever the results you're getting, if you want to generate all that in the form of the visualization also will come along with web app. So directly it will connect you to the web app. A web app will be created. So thereby, whatever the visualizations you have seen, all that can be generated in the web app. So you can try for different labels, and you can try for different conditions, and accordingly the predictions will be changed. So that is a very much advantage of using this Sepash. So you can combine this Sepash with Lyme and SHARP also. So that's why I'm telling there is an advanced tool compared to the previous tools, whatever we have discussed. So you can combine this using the previous other tools also, that is possible. So this block diagram shows the overview of this CEPASH. So if you're seeing here, so it compiles elements of all the steps like data preparation, feature engineering, model fitting, and model evaluation and understanding. So these are the 5 steps. Normally, all the machine learning models will be doing. So what it will do is, it will combine all the 5 steps, and whatever the results we are generating, that will be converted into the web app. So no need of like, we have to write a separate code for that. So just automatically it will convert the web app, and there or in that web app, we can see the dashboard, which can help you all the predictions in one shot. So it will provide you a web app and charts to understand the model better. We can share and discuss our results with clients. The same web app you can download and you can share it with anyone, and it will provide you the summary of explainability. So all the summary also it will provide you in that web app. So this is about CEPASH. So how the web app will look like is like this. So this is a dashboard, or this is a monitor, how it look like. So you can see here CEPASH monitor. So here it contains different blocks. So totally there are around 4 blocks are there. So each block is having their own importance. I'll show you once during the hands-on session time. So there is a dashboard, how it look like. So in one shot only you will come to know all the visualizations with respect to your model. And since no need of separately creating a web app, that is advantage of using this tool. So you can also combine this with other explainable AI tools. That is also one more advantage of using this CEPASH. So compared to the previous tools, this is like faster also, and many things can be done at once using this CEPASH. So it will display the clear and understandable results, and it will make the data scientists understand the model easily, which will be good for them. So these are the tools we have under this explainable AI. Not only this, we have some other tools also like Scatter, Alice, Daleks. So now I'll show you the implementation of these tools, Lime, Sharp, and CEPASH. So what I've taken is here, for this Lime and Sharp, I've taken the dataset diabetic prediction. So whatever like machine learning algorithms, training, testing, prediction, all that steps are common. Even if you want to use any of the explainable AI tools, these steps are common. But the only thing is, you just have to, whenever you're installing that particular AI tool, you have to load that explainable object. That is the only difference you have to see. Otherwise, everything is common. So here, I just have imported the necessary libraries, and then I have divided my data into training and testing. And I've used the algorithm here, random forest classifier. So number of estimators I have given 100, and maximum number of features I have given 2. So then I am classifying, I'm predicting that I'm training my model using X train and Y train, and I'm doing predictions based on testing data. So now classification report is generated. So this is what we are doing normally in all the machine learning. Using machine learning algorithms, these steps are common. So once the classification report I'm generating, so this is what exactly I've got. So you can see here, I've got around the 78% F1 score, and my precision is 87%, and F1 score again, recall 81%. So accuracy 78, so which is not good for this model. Now, if I want to use explainable AI, why my accuracy is decreased or slight low, I can use any of the tools. Here first I have used Sharp. So whenever you want to use these explainable AI tools, you have to install that. So since I am using the Sharp, I am just installing using this pip. So once after installation, it will be loaded. What you have to do is, so any of the tool, whenever you are calling, you just have to call the explainer object. So because since I'm calling all these tools from the explainable, these are the explainable AI tools. By default, I have to call the explainer object because all this will be under this explainer. So I'm calling this explainer object. Since I'm using this tool called sharp, so sharp.tree explainer. So after that, what I have to do is, so you can see here, as I told you, the sharp will give you various data visualization plots in one go. So wherever you want to, for testing data, you want to generate various plots. So different plots are available with respect to the sharp. So one is summary plot. It will give you the summary of all the features. And the next one is you have like, if you want only for one particular feature, you can do that also. And you also have dependency plot. So which feature is depending on others? You'll come to know using this dependency plot. So this is like dependency. And one more you have like, so these are the different plots available with. So if you're seeing here, so if you can see various plot available with sharp. So summary plot is there, summary dot plot is there, bar plot is there, waterfall plot is there, dependency plot is there, single dependency plot is there, multiple dependency plots are there, force plot is there. So I can generate multiple rows depending on that, some plots. And then I also have single force plot and decision plot. Is this demo screen is visible now? Okay, so here, see what I've done is I just have taken the data set. So the data set I've taken is breast cancer data set directly downloaded from the Kaggle. So all these are the basic things what we are doing with respect to machine learning. So training the data, pre-processing, training the data, then dividing the data into training and testing, and then applying the machine learning algorithm. So all these are common here also. But after applying the machine learning algorithm and predicting the result, we'll be using this additional thing, explainable AI tools, in order to get the result more interpretable way. That is the only extra thing we are doing here. So here I've taken breast cancer data set and I've divided that into training and test data. And then what I'm doing is I'm splitting the data into training and test data. And then I've used the XGBoost classifier for predicting the result. So you can use any of the algorithms. Here I've used XGBoost. Either you can use a random forest classifier also. So accuracy score I've got 95.61. So this everyone knows these are the basic machine learning models what we are doing and all the basic steps. But after this, if I want to see more in depth about my result, so what I'm doing is now I'm just installing Sharp. So in order to install this Sharp, I'm just calling this pip install. If you want to install Lime, you can just give pip install Lime. And if you want to install Sepash, pip install Sepash. So there is a simple step for installing. So automatically it will be installed. So either I'm calling Lime, Sharp or Sepash. The common thing what you have to do is all these are explainable AI tools. It will be stored in that explainable object. So I have to call that explainable object. That is the only thing we have to do. So when I'm importing the stuff, after installing, I have to import this. So when I'm importing, so I just have to call this explainable object. So this tree explainer is nothing but where exactly my sharp, lime, and this Apache will be stored. So I have to call this tree explainer, and thereby I'm giving this model, whatever I have trained my previous data. So after this, what I'm doing is I need visualization with respect to sharp. So these are the different visualizations you can show with respect to the sharp directly. So no need of writing any separate code for that. You can see all in one shot only you can see. So I can see summary plot with respect to individual values, and also summary plot I want a dot bar, that also I can categorize. I can also generate waterfall plot. I can also generate dependence plot, single dependence, multiple dependence. And with respect to multiple rows and single rows, I can generate force plot, and also I can generate decision plot. So all these are the basic plots, visualization plots available with respect to this sharp library. So what you have to give for every plot is, you just have to give the title, and you just have to give for which values you want to generate the plot. That's it. Apart from that, need not to give anything. The only thing with respect to these tools is, you just have to call the explainable object, and then you just have to call with respect to sharp all the visualization plots you can call. With respect to line, what analysis you want, you can give that. With respect to Shapash, you can give the web app. So these are the three different things we have with respect to three tools. So after calling this visualization plots, you can see this is how my output will be generated. So all the different visualizations in one screen. So here the first one I've given like this is summary plot. So all the features with respect to summary. So you can see the high value, the highest value is highlighted in pink color, and the least value with blue color like that. So which one is having highest, all that also you can see. And this is my individual which feature is having the highest value. So according to the feature wise also, it will be sorted, and it will be all the highest value. This mean similar low value. So this also you can see using this sharp. And then is, if you want instead of these values to be displayed, that is also possible. Correlation between the values, and then dot matrix between the values, dependency between the values. Any values are depending, and features are depending on the features and all. That also you can see here. If individual feature, what is the value? What are the values with respect to each feature? Also you can see. So this is each feature, and this is like a decision plot. So which feature to be considered and which feature not to be considered. So it will give you the decision plot summarizing all the features. So these are the various plots you'll come to know using this sharp. So if you're seeing this decision plot only, you'll come to know which feature to be selected, which feature to be not to be selected. That also you'll come to know like which one to be considered and not considered. So this is important explainable AI tool, made your entire data in depth. So now coming to line. So line also you can use for the same data set. So what you have to do for that is, so you can see single dependency plots, multiple dependency plots, all of that. So this is dependency plot I want with respect to worst conclave points and mean conclave points. So how it is dependent. So this is the plot for that. And I want dependency plots. So this is multiple dependency plots on different features. Then you have Bayesian plot as discussed. So coming to Lime, so just you have to install the Lime using this pip library. So pip install Lime, it will be installed. And what you have to do is here, you have to import the packages. So after installing, you just have to import that particular package. So after importing, as I told, you just have to call the explainer object. So when are you importing Sharp or Lime, you just have to create this explainer object and you have to call that. So since I have to call this explainer object, so that is like tabular explainer, and from where I have to for what data I have to apply this Lime is for test data. That's why I've given test data. And what are the features I have to consider is all the columns. And what is the target variable is 0 and 1. And then directly I can give the, it will show you the visualizations. So for visualizations, the dashboard will be like this. This is the dashboard with respect to Lime. So if you're seeing here, you have three things here. The first one is the prediction probabilities. So in the target column, if you have only 0 and 1, which is having more prediction. So in this case, 1 is having more prediction. So compared to 0. So the first column only, it will show you the prediction probabilities. Which one is having, whether, which feature is having, whether 0 is having or 1 is having. In this case, 1 is having. And the second thing I have, if 1 is having the prediction, based on what feature it is having the prediction, you can see all the values in the range of this. It is giving the values also, which range it is there. So with respect to all the features it is giving, that is the second column you have. And the third column you have is the orange color indicates the 1 and blue color indicates the 0. So which features are contributing to that 0 predictions and which features are contributing to the 1 prediction. That also you'll come to know using this Lime. So this is the dashboard with respect to Lime. So three things you will come to know. One is the prediction probabilities with respect to the feature, and then individual feature with respect to the positive prediction or negative prediction, and which feature contributed to both the predictions. So this is the dashboard, how you can see it look like with respect to Lime. So these are the two things I've taken for breast cancer dataset. And now coming to CEPASH. So for CEPASH, I've taken Titanic data. So this CEPASH, you can see it's an open source library. So directly you can log into this cepash.ai and then you can execute there only. So cepash.read docs, you can go and you can execute there only. So if you're seeing here I've taken Titanic data. So for Titanic data, what I've done is all these are the basic things, machine learning things, what we are supposed to do. So importing all the things and classifying the data into training and test data. And then here I've applied random forest algorithm. So random forest algorithm I've applied for this Titanic data. So once after applying random forest algorithm, what is the next step I have to do is I have to call this CEPASH explainer. So if you're seeing here, what I have to do is I have to install the CEPASH, that is pip install CEPASH, and then I have to divide all that into training and testing, all that basic things. And I have to call this explainable object. So smart explainer object. So this step is common for all the three tools, either Lime or Sharp or CEPASH. So you just have to call the smart explainer object and then you have to compile. So this is the only extra thing with respect to CEPASH. So whatever the smart explainer object you are calling, after that you have to compile the extra testing data, and then this is for regression model I'm doing. That's why the model name is regressor. If it is a classification model, you just have to give classifier. Okay. And then my prediction is based on the test data. That's why I'm giving this Y prediction. So once after this, after doing this compile step, you just have to launch the web app. So how to launch this web app is you just have to run this app. So this, as soon as you're running this web app, a pickle file will be created automatically. So this XPL is nothing but pickle file. So this pickle file is created automatically. So whenever you're using this, you want to use the same web app, you can run through this pickle file. So the xpl.run app, it will give you the directly web app connectivity next time when you want to use. Okay. How this web app will look like is, so as soon as you're running this, your web app will open like this. Door close. So, so this is how your dashboard will look like. So there is a web app dashboard. So as soon as you're executing that line, this dashboard will open. So if you're seeing here, there is a monitor. So this is a monitor for the Titanic data set. So you have here 4 different columns. Feature importance is one thing. And the second one is you have data set filters, true values versus predicted values. And then you have third one is, this is considered as, the first column is feature importance. And the second column, I will be calling it as contribution plot. And the third column, this third one, I will be calling it as local plot. And the fourth one, I will be calling it as selection table. So these are the 4 tables you will be getting in this web app. So this is called, this will be calling it as Apache monitor. So I'll show you now how you can play with this. So the first one you can see, in the case of Titanic dataset, all these are different features. I have features like sex, ticket class, age, title of the passenger, from where they boarded, what is the and whether any sibling or spouse they have landed or boarded into the Titanic ship. All these are the different features that are there in this Titanic dataset. So among all the features, you can see the sex, whether a male or female, the passenger means details, whether male passengers or female passengers, it is contributing 32%. And the ticket class is contributing 18%. Age is contributing 11%. Okay. So now you can see here on the right hand side, you have index, prediction, target. These are the different features we have in this Titanic dataset. So we have this prediction is based on the target. Age is there, embarked is there, ticket fare is there, parent child, how many are traveling, how many parents and children, what is the class they're traveling, what is the sex, and then how many sibling and spouse they're traveling, and what is the title. So all these are like my data set overview. If I want to filter through any of the feature, I can do here straight away. So I just have to click on this add filter. If you want to filter through age, I just have to give age. I want to see now how many are there in the range 0 to 50. I just have to apply. So you can see here, this immediate, the next diagram, it is changing based on whatever the filter I've applied. The first diagram also changed. The first diagram also changed. So as soon as age between 0 to 50, these many are having. The highlighted one sees like contribution also. So you can see the age is contribution also. Like that, whatever the filters I'm giving, the diagrams will change automatically. And if you're seeing here, so you can see how many have survived, how many have died. So depending on this age group, I can come to know male or female from this feature contribution diagram. And now here I want to select the threshold. Like I want to give index. Suppose the data set I have like index, it is 9 or 14. I want to select based on the index 14. So just click on that 14 and age. So you can see only based on that particular index 14, all these plots are generated. So index 14 is nothing but Southampton. This is the he landed into the ship. So based on that index 14, all these diagrams will change. So if you want to display only some 2-3 features instead of 8, I can give here the selection. So I want to display only 4 features. It is displaying the 4 features. I want to display only 3 features. It is displaying the 3 features. I want to display only 1 feature. it is displaying only one feature. So that feature selection is also possible here. So on what basis this feature is selected is top 10 features will be selected. So if you want to display, it will display the top 6 features. If you want to display 8, it will display top 8. If you want to display 1, like that. So this feature selection you can do here. How are you modifying the values? The corresponding is it audible and visible, right? Screen is visible, right? Screen is visible. The screen is visible. Can someone say yes or no? Okay. So this is how this Apache monitor will look like. So as soon as you're changing any of the values, automatically all the other values, other features, it will change depending on whatever you have changed. So this is like what index you want to display. Based on this data set, you'll come to know. Suppose I want to know the index with respect to 18. So I can just click here, and here you can have different classes like whether the passenger survived or death. These died. These are the two classes you have. So if you want to see more analysis with respect to how many people died on all these features, you just have to select the depth class, and accordingly, all this will be changed. So this is more focusing on the died column now feature. So if I want to find out the index, you can see here, this is with respect to the index, the male is having this many numbers, and the Mr. in that, and from where they boarded on, and what is the ticket class, all that with respect to this 18 ID, you can see this. This last table is considered as selection table. So based on the selection, which ID you want to display, that particular ID you can select and it will be displayed. And the before table is called as local plot. So it will give you the features the most it is contributing. So since everything I'm selecting with respect to the target column now died, how many people have died, so everything it is showing you this red color. So ID 256, 814 like that. And this first column is feature importance column. So which feature you're selecting, accordingly, the diagrams will change. If you're selecting here age, you can see different thing will come, title of the passenger, and what is the fare. So accordingly, the images will change. So this is how, and you can see correspondingly the true versus predicted values. How many people have died and how many people have survived. That also will come to know. So each means a point, it will give you there only what is the ID, what is the predicted value, what is the predicted class, what is the true value, everything you'll come to know here. So that is the advantage of using this Sepash. The entire thing in one shot. So this web app, no need of writing any code for this. As soon as you're executing that, launching the web app, this monitor will open and you can change different values and corresponding graphs will be changed. So using this Sepash, you can also combine this with Lime and Sharp and can be combined with other explainable AI tools also. So that's why this is like powerful and widely used explainable AI tool. If you want to know more analysis in your machine learning models. Okay. So this is with respect to Sepash. And coming to this literature review tools. So in literature review tools, there are many popular literature review tools are there. So advanced, I'll show you what the tools available. So these are the different tools that are there. So in literature review, we have this Skype space, consensus AI, elicit, reference and write. So these are the 4 tools, means easy and most popular tools that are there for literature review. So among this and for general AI tools, these are the different tools along with apart from chat GPT. So this Copilot, I think yesterday's session he has explained about in depth about this Copilot, and we also have Word, Chat Doc, Explain Paper. These are the tools mainly for research related. So if you want any of your research paper in depth on that paper, if you want to provide, so you can give this explain paper. So this explain paper, what it will do is as soon as you upload the paper, it will summarize, it will give you the summary one shot. Paper digest also will do the same thing. This Gen AI, what it will do is scientific writing. So if you want to rewrite anything, you can make use of this Gen AI. So now among these literature review tools, I'll show you this elicit. So this elicit is one of the tool which is easy way you can generate literature review. When you're writing any literature survey paper, normally we have to study more papers, understand, and then only we will write the summary of the each paper, drawbacks, all that. So at least we need some time to go through all the papers. Using this LSC tool, what it will do is, as soon as you are uploading the paper, it will give you the summary. It will rewrite the, it will give you in the form of the literature. So what is about the paper? It will provide you. And if you're just giving the topic, in this topic, I just want some papers. It will suggest you all the latest papers. And also, it will also summarize in the form of literature. So that is the advantage of using this LSC tool. So for this, it's a free open source. You just have to register and plans, basic plan you can select. So in the basic plan, it will give you the summary of the literature based on the papers, which I think that is fine for faculty. So what you have to do is, as soon as you're registering into this LSC, you just have to, here you can see notebooks and library. In library, you can open any number of papers. So based on the papers you uploaded, it will give you summary of that papers, as well as whenever you're logging in next time, it will show you what are the papers you have uploaded. Okay. So notebooks are nothing but different questions or different thing what you want to ask. So in this case, I just asked like suggest papers on XAI. So it will give you like top summary of the top. I got around 4 papers. So as soon as, or otherwise I'll give you like instead of summary papers on Copilot. So you can see here, I've got some papers, empirical evaluation of GitHub Copilot code suggestions and Copilot AI pair programmer. Some articles also I've got. So some papers, wherever this Copilot is there, it is giving me all the GitHub and Copilot things. So along with this, it is also giving me the summary of all these papers. You can see here. So all these papers, it is giving me the summary. So this LSC tool is mainly used for literature review. So you can upload either papers, it will give you the summary of the papers, or if you want any particular topic, you want some papers to be suggested, it will suggest the papers as well as it will give you the summary on that paper. So this summary we can see and we can mention as literature survey. So this is a very good tool, can be used for literature survey with respect to of any of our papers. Okay. So this is one tool which I've explored and I want to show you this. So other tools also, notebooks will share with you. So this is about my topic today. So if any questions you have, you can ask me. We have one more speaker joining now at 11 o'clock. So if any questions, you can ask. Okay, thank you.
Thank you, ma'am. Thank you very much. Your talk was indeed enlightening for us, and this was a refreshing talk which our academicians can make use of. Thank you very much for sharing your knowledge with us today. Dear participants, up next we have Mr. Sudhanshu Saurabh. Mr. Sudhanshu Saurabh is Assistant Professor at East Point College of Engineering and Technology, Bangalore. He has over 19 years of experience. He holds MTech degree in Computer Science from Institute of Electronics and Telecommunication Engineers, New Delhi, and MSc degree in Electronics from University of Lucknow. He has worked at Eventure Technologies as software engineer, project consultant at Tiranga Aerospace and institutions such as RKG Institute of Technology, Indraprastha Engineering College, RD Engineering College, Ghaziabad, and Greater Noida Institute of Technology, Greater Noida, in various capacities from a lecturer, senior lecturer, and assistant professor. He has served as resource person and invited speaker for various workshops, conferences, faculty development programs in various universities in Noida, Dehradun, and Surat. He is member of various expert advisory committees constituted by Commission for Scientific and Technical Terminology, Ministry of Education, Government of India. He served as an expert member of Glossary of Information Technology, Glossary of Nanotechnology, and Glossary of Insurance with CSTT from Ministry of Education. He has published 5 papers in peer-reviewed and refereed journals, which are listed in SCI Index journals, Scopus Index journals, and conferences. He is an active member of various professional, scientific, and technical associations like ACM, IETE, and ISCA. Today, Sir will be talking about image extraction and identification using deep learning. Saurabh sir, very welcome to you. Over to you, sir.
Am I audible now? Hello.
You are audible, sir, and your screens can be seen.
Okay, sir. See, the today's topic, my topic is image extraction and identification using the deep learning. In this, the purpose of object detection is to identify and locate one or more effective target from a still image or the video data. See, if video data specifically is there, then it's a difficult to detect the object. For example, if object is moving zigzag format, so it's a difficult to fix the camera or particular object for the detection purpose and the recognition purpose. For this problem, AI provided the technique. That technique is detection, and the tools are there. That tools you can use uh, fast RCNN, faster RCNN, OpenCV. OpenCV means that open source computer vision. That is a library which is developed by the Intel, and the maximum number of contributor in the OpenCV is from the Russia, Intel Russia, and it was launched in 1999 by the Intel. So OpenCV is very much useful for the object detection. So that's why this still images and the video data we can identify using the OpenCV along with the machine learning and deep learning models. It is widely include a variety of important techniques such as image processing, pattern recognition, AI techniques, ML techniques, deep learning techniques, and most importantly, it has a broad application prospect in such area like uh, you can say the traffic, road traffic, accident prevention, warning of dangerous goods in the factory, military restricted area, monitoring, and the advanced human computer interaction. While the application scenario of the multi-target detection in the real world are usually complex and the variable, and balancing the relationship between the accuracy and the computing cost. This is the most important thing. The, so the variable and the balancing relationship between accuracy and the computing cost, it is a very difficult task for that purpose. The object detection from the video frames has already been notable research direction. And see, uh, the focus of computer vision nowadays, why it is important? Because the classification of the images, classification of the object, classification of the other things while we want to detect, and after detection we classify. See, the class activation map are there while we are using the deep learning models, and layered architecture are there. Though those hidden layers, the classes are there in between those hidden layers. See, the depth of the layer, which is counted by the total number of hidden layers. By this way, you count the depth of the model. So the image is generated by those hidden layers. That is a class activation map. So once the image is generated, so first you detect, after that you have to classify these things. So the more uh, notable research in this particular direction is focusing the computer vision. Means the image should be there and the camera should be there. Both are combined together to generate the activation map of the image. So why? Because see, these things are most widely applied in the automatic car, robotics, video surveillance, pedestrian detections. These are the application area of this computer vision. And the experience of the deep learning technology has now changed nowadays, because traditional way of the object recognition and the object detection are different, totally different from the this deep learning and machine learning along with the OpenCV models. All these three are combined together and gives the more precise result than the uh, older techniques. Means the traditional techniques what we earlier used. So the deep learning neural network has a vital feature representation capacity, first thing, in the video frames, and the feature extraction module are also used in the feature detection. That's why the CNN model so much useful. Now I am talking about another uh, CNN model, that is called region-based CNN model. The region-based convolutional neural network, it 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 achieved the excellent object detection accuracy. Because see, if image is there, it means that some certain area are there, some perimeters are there. So how to detect those perimeters? And many algorithms are there, like Euler Jones algorithm, HOG algorithms are there, histogram object gradient, HOG. So very old algorithms are there, but nowadays those algorithms have a .xml file, so you can directly use those .xml files and detect the regions. But once you are using the deep learning models, that is a convolutional neural network model, so apply the region to use those algorithm in the CNN models, then it becomes RCNN. And once it is RCNN, then that deep convolutional network to classify the object, first thing. But it is not fast. This RCNN region-based CNN model is not fast. So it is just slow, and it performs the very very slow manner, because that is a forward passing kind of the network. That's why, because all the CNN model is a forward passing kind of the model, that's why it becomes a slow. Why it is slow? Because once a region is there, so region means that you can say that with perimeters with respect to the image, it takes a time to pass to the next layer, next hidden layer, to next hidden layer. So see, if the depth of the convolutional model is 48 layers, then how much time it will take? Like VGG16, VGG16 is a 48 layer depth, and mobile net is a 28 layer depth, and LXNet is a more than that, more than 100. So because of these much calculation, it takes a time. So faster, this RCNN is a slow. So for how to uh, increase the speed of this RCNN, the another model comes in the picture, that is a fast fast RCNN, then faster RCNN. So many models are there. We'll discuss later. So these communication is this communication between the two person or the two parties, that image and video, this kind of the data are most important to provide the communication between a two or more than two communication parties. So for that purpose, how to analyze that data, automated analysis is required. That is very much important thing for the automation purpose. That deep learning model is very much important. It will play the vital role to analyze the information. And that video is consisting a time series data, that is a sequence of images. So if 10-second video is there, then if time is minimum, then the number of frame is maximized while converting the video into a images. Directly you cannot analyze the video. First, you convert the video data into an image with respect to the time, then it becomes a time series model. The continuous time series becomes a discrete model. After that, you have to perform the analysis, apply your algorithms and perform the analysis. So, according to the IDC, the maximum number of communication through the uh, image dataset or the video dataset nowadays happening in the internet world. So that computer vision and deep learning technology, how it works and what are the area nowadays most widely used, that face recognition, object detection, motion recognition, and these are the application area. And see, this is a what I performed. See, these are the object. First, few students are there. They are having school bags and they are moving. This is a video data. What I did, I converted this video into a images first, and after that apply the region-based algorithms. Those algorithms are generates a bounding box. So see, this is a raw image. In this raw image, we have to generate the bounding box, the number of objects which is available in this particular landscape. So in this landscape, you can see the regions are there along with the name of the object. And if you want to generate the probability, how much percentage of this particular object is, like if it is a bad, so how we can recognize? For that purpose, you have to perform some calculation, and that is a probabilistic kind of the algorithm. Apply any kind of the probabilistic algorithm, and that probabilistic algorithm is responsible to generate the probability along with the name around the this bounding box. So this is the first thing. Second thing, see, this is a technique, object detection technique. First, what you will do, collect the data, raw data, convert raw data into a labeled data, and write your own algorithms for your model. Means if it is a machine learning model, then you can write your own algorithm, integrate your algorithm with the given, because that machine learning algorithms are available, 10, 11 algorithms are there. Integrate your mathematical model or the algorithm with a machine learning algorithm or the deep learning algorithms. Both are combined together, and then apply the region proposal network, RPN. That is also one kind of the deep learning model. So RPN you can apply. Inside the RPN, many mathematics are there. That mathematics is based on the computer vision. So because image processing and some hardware CPU related, both things are there. So in the OpenCV, because it is CPU intensive kind of the programming, OpenCV. So both are combined together and it will generate the region proposal. This is the latest one. But if you want to use Euler-Jones algorithm, then you can use Euler-Jones to generate or histogram oriented algorithms. You can use here also instead of this RPN. But that bounding box which is generated by this your algorithms along with the machine learning, deep learning, and this RPN, you, if it is a Euler-Jones and HOG, then bounding box is a little different than the RPN network. So better to use the RPN. After that, this complete whole model generates the visual features of the video data set that is already converted into an image. And then it will generate the post processing. It means that along with the name and the probability around the image are there, that is a post processing. Now check if two bounding box, because two objects are uh, besides each others, then what will happen? Two bounding box are overlapping with each other. Then the problem is there, which one, which object is having the maximum probability than the other object, and which object you want to detect, because two bounding box are there. Your algorithm is responsible to detect all the objects which is available in the image. So segregate it. For that purpose, remove the overlapping. See here how to remove the overlapping. Just now I to speak about fast RCNN, faster RCNN. So actually RCNN is a base model. Then increase the speed of the RCNN. R is stand for the region and CNN is a layered architecture. So it is speed is totally depending upon the region, that kind of the pattern which is available. So increase the speed. How to increase the speed? For that purpose, the feature map technique, convolutional feature map, you have to work on the feature map, and each object proposal a network of the each not network, region of interest. So you have to write the algorithm, region of ROI algorithms, and those ROI algorithms is based on the but specific, it is specifically related to the image, because each image is a different ROI. So for that purpose, the ROI algorithm is different. So change the algorithms and generalize and formalize the algorithms. Once it is generalized, then it's easy to integrate with a CNN model, and it becomes a fast RCNN. So why it is, again, the fast RCNN is not so much fast. So another a modification comes in the fast RCNN, that is called faster RCNN, which is composed of the two modules. The first module is a deep, fully convolutional network. Fully means that dense, completely dense model. So that's why it is called deep, fully convolutional neural network, which is responsible to propose the region. This is the first. And the second module of the faster RCNN is a detector module. That detector module called a fast RCNN detector. Fast RCNN detector. This is the second module. The first module is a RPN kind of the module. So both are combined together, and then it becomes a faster RCNN. And this entire system is a single unified network for the object detection. So these two algorithms, fast RCNN and faster RCNN, are very important for the object detection. Now, the histogram oriented gradient, this is an algorithm. Nowadays, easily you can download, because .xml file is available, and you can use in your programs and apply directly, and it will take care of the this bounding box. So region based RCNN, this I discussed earlier. Now region based fully convolutional neural network. Fully convolutional neural network means uh, one single layer is there. In hidden layers, the numbers of hidden layers are there. You have to insert one more layer, that is a dense layer or fully connected layer, put inside the hidden layers, and then it will be this fast RCNN becomes a fully convolutional neural network based on the region. So that's why it is a region based fully convolutional network. Another algorithm which is easily available on the internet, SSD, you can download, and SPP network. SPP network is also very important. It is then spatial pyramid pooling algorithms. This is a also a convolutional neural network. Then, but once you are using a CNN, then no need to use a spatial format. Otherwise, if you are not using this CNN, then better to use a spatial pyramid pooling. Otherwise, no need to use it. And another kind of the algorithm nowadays given by the darknet, that is YOLO. Most of the people, most of the companies nowadays they are using, because it is easily available on the internet, and you can download and you can use for the generating a uh, this bounding box. For this bounding box, YOLO is responsible to generate. So you can download and you can use it. So look at here, how to extract the complete framework. The raw data is there. Convert those raw data into a images, then extract the feature extraction techniques. So this is the extraction level, frame level, and video level. If frame are there, then apply the machine learning kind of algorithm, non-machine learning kind of the algorithm. If machine learning algorithms are there, these are the extraction methods: machine learning, non-machine learning, traditional technique, and machine learning technique, or the deep learning techniques. And these are the features for any particular image. You can write here the features, and the features are here: the quality, resolution, collect these characters of the colors, like many colors are there in the image. Then you can check the features. Similarly, if video is there, so directly you cannot detect and recognize, so that it's a difficult. So for that purpose, the machine learning and non-machine learning, the variance you have to calculate, apply the statistical technique, check the variance in the uh, uh, mm, those you can say like you can say those perimeters. I mean, the variance in the perimeters or the convex hull kind of the property, you can apply and check the variance of the particular image. So better to convert into a these videos into a images. This is the only technique. And if non-machine learning techniques are there, then scene cut, duration, this is a traditional technique, and these are the features you have to analyze. See, look at here, complete that what I did. First, download the video or real-time video, anything. So this is a video data set. Select randomly a single data at a time. Select single data, and then those single data is called random selection technique. Apply the random selection statistical technique, randomly you select, and then apply the framing algorithms. By the framing algorithms, this video is into a images, converted into a images. This, once it is into a image, then you have to generate the contour or you can say the bounding box around the image, apply the algorithms, and then uh, you can easily detect. See, look at here. The techniques, this is very old techniques, 45-year-old technique, Kenny edge detection algorithms, and other algorithms is also there. So you can apply any algorithms and apply the Hout transform and then detect the contour. How to detect? So Kenny edge are performed by the Gaussian blur, see, and the CV2 dot Kenny. CV2 is a OpenCV package. So that's why import OpenCV and then you can use the CV2 in the Python programming. You can use the CV2 dot the name of the algorithm, and then this algorithm is itself take care of the uh, those bounding box or the contour. Because see, but this Gaussian blur and scanning is not very good technique. So see, the image, this image, I taken this particular image. This image actually I was taken this image. So it is converted into a mm, images or the frames with respect to the time, because time, if time duration is small, then the number of frames is more. If time duration is bigger, then the number of frames is small. So use a smaller time duration and then generate. So select anyone. Then again you have, for the selection purpose, select any random image. Apply the random selection technique here. Again, the same technique what we applied in the video, same technique you have to apply here for the random selection of the image, and then apply the Kenny or the Gaussian blur, and then you see here the some rest of the uh, see, maximum part of this particular image are the black and some part of the image are in the gray. So why it will happen? Because of this Gaussian blur and the Kenny algorithms. So once you are invoking these two algorithms, then it will generate like this kind of the image. Then how? See, another technique. Instead of this, if you apply the Hawk transform, then functions are there: circle, Hawk circle, Hawk line, and blend image. How to invoke? Again, you have to write the OpenCV. Directly, you can write the OpenCV.HawkLine or the CV2.HawkLine. By this way, you can generate. So see, some these contours are generated from this Hawk line functions or Hawk circle functions. You can use both together or at a time only one you can use. No problem. And it generates, see, the blue colors contours are generated around all the object, I mean all the images which is available over here. And another technique, another algorithms which generates much better contour than these two. They are the dilate, find contours, draw contours. It is written by the Intel OpenCV people. So these algorithms, these function, I mean algorithms work with CPU directly. So it generates the contours around the images. See, the API which is available. See, this is a raw image. This raw image is random selection. Look at here, this image. This is a video, and image are here, random selections. And after this, instead of this contour generation, after this, you have to directly apply the bounding box algorithms, which is given by the OpenCV, Intel OpenCV. So apply here, load the images, and after that, har cascade .xml file. That har cascade means HOG file. What I earlier discussed, this histogram oriented, this HOG. Apply here cascade.xml. You can easily download this. It is available. And then apply here. And then write some source code, that is a script, and see it generates the bounding box. But problem is so much problem. See here, consider these two bounding box. They are overlap with each other. Here, two bounding box, they are overlap with each other. So which object exactly you are going to detect, it creates a problem. So for that, see, if I am selecting this particular object, what I am selecting, so it is extracted here, and see, this is overlapped, overlapped. Remove this overlapping. How to remove overlapping, and then finally you can detect there are procedures, or you can use inbuilt procedure in, from the OpenCV. I mean the functions which is available in the OpenCV you can use. Otherwise, you can use you you can write your own algorithm to uh, uh, this remove the overlap. So both you can use. It depends upon your project. See, the extracted images are here. The check whether it is RGB or whether it is gray. If it is RGB, check the shape. If RGB is there, the dimension are 3. If it is gray, obviously the dimension is 2. Check the value of these two shapes, and then convert this data, this shape, into a NumPy data. Because if it is a simple numerical value, then it's a difficult to process in the deep learning or the machine learning model. So better to convert those data, those numerical value into a NumPy. Once it is in NumPy, then those NumPy means uh, uh, machine readable format, Python readable format. That's why all the numerical value will convert into a NumPy. So see, this is these size and the pixel values, that is also known as a signal. You don't say signal directly. You can say the intensity of the color. Those intensity of the color is converted into a signal, and those signal into a numerical format. You can say pixel values, numerical, and convert the numerical values, those pixels, and then finally can train. So look at here. This numerical data will process NumPy data, you can say, and then it is generated for this particular image. The Gauss, once you are applying the Gaussian filter, then numerical value are different. Once you are applying the HOG, then the numerical value has been changed, and then other techniques, many techniques what I discuss here, this rcascade.xml, this canny technique, this hog lines, hog circles, find contours, any techniques, the numerical value are totally different from each other, and the color intensity distributions are see here. If it is RGB, then color intensity for each image is different. And look at here, for the gray image, the color intensities are showing here for the gray image. If it is gray, then their color intensity is like that. And the complete image details are generated by the programs. Program means that software, what you wrote, what you written, or what you are going to write, then it will generate the image details into a NumPy format. Again, you have to uh, uh, convert the NumPy into a original numerical value, and then those numerical value again it generates the image. See, How it will happen? This is the first part. Now, this image detail apply into a post-processed model. Actually, this is applied to a deep learning models, fast RCNN, faster RCNN, SPP network, image network, anyone. So whatever kind of the CNN model you like, you can apply, or YOLO algorithm you like, you can apply. So apply the deep learning models. Those deep learning models are used for many different things, for like speech recognition, because the speech is there, then the video data is there, then you have to recognize the speech also, many other things. So because in the video data, image is there, voice also is there, speech also is there, so you can recognize it in everything. Analysis means you have to analyze each and every aspect of the video. So deep learning models will take care of each and every aspect of the data. So following concept, image nowadays this ImageNet data set and model both are used used by many professionals and many companies. They are using Coco model also, and this for that purpose your hardware is like that, so that CPU clusters are sorry, GPU clusters should be there, or you can use the CUDA model instead of the GPU. See, in the deep learning, the data day by day, the amount of the data is increasing. Once the data is increased, then your hardware is like that to process that much huge amount of the data. If the data size is less, then it's easy to process the data. But if the data size is more, then it's difficult to process the data. Therefore, you have to increase the capacity of hardware. Those hardwares should be uh, mm, efficient to calculate the maximum number of numerical values. That numerical value means the numpy value. For that purpose, the graphical GPU are required and the CUDA model is required. So what to analyze the speech. If video is there, then speech you have to, because voice is also there. So that you have to analyze the speech pattern. It means that the shape of the image. And if you want to check the psycholinguistic value, linguistic value, what kind of the voice is generated inside the image, that video, what is the meaning of uh, uh, those words generated by the person which is inside the video, or if see the vehicle is there, so vehicle is there, so you are going to detect the vehicle, but if horn is generated, that some sound are generated by the machine, then you have to detect the sound also. That is the usability of the deep learning. And other things, many other things, so you analyze all the aspect of the video data, and then recommend. Recommend means if it is a automated driving, automated car is there, then what kind of the data it receive and analyzed by the complete machine, complete system, by the complete system which is installed inside the car, and then car will represent, recommend, okay, you take the right direction, right turn, you take the left turn, object is there, so that's why recommender system, so all are combined there. So by this way you can analyze. And how to see how to train. So for example, MNIST data are there, then the epoch and iterations, these two things are there. Each and every epoch, the many iterations are there. So iterate the data, it depending upon the size of data. So epoch you take carefully. how many number of epoch, because it is a very important parameter. You can say the hyperparameter. It is very important because your efficiency and the accuracy of your model and the cost of your model and the loss of data, because once you calculate the accuracy, then automatically you can calculate the loss of the data. So each and everything is depending upon the epoch, how many number of epoch, what is the size, what is the batch size, what are the hyperparameters you are using. So please take carefully, write all those things properly. See, this is a generation, model generation. The first started, this deep learning techniques started for the object detection in 2013. The first model was detector net given by the CSE between 13 and 14 somewhere. And most widely used RCN and region-based model given by the GCEM. This is a very famous model actually. Multi-box is not so much famous, and overfit model is also not so much useful, but they publish a paper. But this paper was very much famous. Easily you can check it. And then for the detections, VGG net, another model, VGG network developed by Oxford people. So two variants are there, the 16 and 19. The depth, because why it is 16 and 19? Because of the depth of the hidden layers. So the number of the hidden layers, that's why it is a 16, VGG 16 and VGG 19. 48 layers are there in the VGG. And Google LeeNet, CJD. Earlier it was known as a LeeNet, given by the Yakun, Lee Yakun. Now he is a meta scientist, Yakun. And later, earlier it was known as LeeNet model, but later it is that model is enhanced by the Google so that it becomes Google LeeNet. And just now I discussed SPP network. So SPP network is not that much useful. So better to use the VGG net, RCNN, or the Google LeeNet. But Google LeeNet performance, sometimes it performs good, but sometimes it is not perform good depending upon the type of data. So VGG net is better than the Google LeeNet. And another model is given by Sedeti. This first model he was given, and another model, the multi-box model. Multi-box, why it is called multi-box? Because the bounding box, several bounding box are generated, but they are not going to overlap. So that it is a multi-box model, and this is a better model comparatively the RCNN. And fast RCNN, faster RCNN, both are almost the same. And now next, this YOLO algorithms. So given by the Redman, uh, because see why it is most widely used, but it is easily downloadable and you can change in the YOLO. You can change one or two line of a code and then you can use for your on data set. You can detect. And ResNet is also good, but not that much. And SSD it perform better. This SSD algorithm perform better. That Liu. Actually, this Liu et al. They worked with Lee Yakun. Liu and Lee Yakun both worked together to uh, for this LeeNet model, and independently he worked and he wrote the algorithm, that is SSD algorithms, single shot detector algorithms for the bounding box generation purpose. So that is also good. And this region faster CNN models, just now I discussed, and this is good but not that. But DenseNet is good. DenseNet model, you can use the YOLO, VGG net, DenseNet, RCNN, faster RCNN. But sometimes what happens, this mask RCNN, if you want to generate a mask on the image, so that you can apply the mask RCNN algorithms. Otherwise, no need to use. And later, this retina net and the corner net, these two models are there, but not so much used, not widely used in the industry, retina net. So better to go for RCNN, VGG net, YOLO, mask RCNN, and YOLO. This YOLO 9000 and this YOLO, it's better to use YOLO. Don't go to Redmond and Faraday model. Better to use the Redmond model only. So these are the deep neural network which is used for the object detection. OpenCV is integrated in all. See how it works. It will work. See, pixel are here, images are here, the neurons are here, means layered architectures are here, and it generated how it works. This is a complete framework. So deep neural network are there. Multiple MLPs. If you want to use MLP, then you can use MLP. Otherwise, no need to use the MLP layer. You can use CNN and RNN, both. These two. Through RNN, you can generate through CNN. So today I discuss only a CNN technique, and through this you can detect. But you can apply the RNN. Mostly that LSTM and all the 5 variant of the LSTM you can apply, like stack LSTM, by LSTM, vanilla LSTM. So you can apply the LSTM models. But LSTM models are these are this LSTM is a enhancement in the RNN techniques. That's why that is a long short-term memory. But this LSTM is mostly used for the large language model and uh, this NLP techniques. So better to use the CNN, but you can use if you want to analyze the linguistics and other things into a video, because see the person is sitting inside the vehicle, and if he is speaking something and we want to check what he is speaking, what kind of the word he emitted from his vocal cord, then we are analyze to apply the LSTM models combined with CNN models. CNN model means all these models, anyone. So combine this and it will become a hybrid, and then it will take care of the analysis of the voices. See, the framework, which framework is better? So nowadays people are using the TensorFlow, Keras together, and PyTorch also. But except this, other models is also there, and those Theano and Cafe, because 7 to 8 years back, the Theano was so much uh, useful for all this kind of the analysis, and the MXNet, this was also very much useful. So, and Cafe is specifically, see, the Cafe that is given by the some NVIDIA people, and while you are using the CUDA, then better to use a Cafe instead of the C++. So this Cafe model is also very much useful. See, if satellite SAR data is there, if SAR data is there, then that data is always in the uh, gray format. But many informations are hidden those gray data set. So for that purpose, Cafe is very much useful. You can apply the Cafe and extract those informations which is hidden in the gray images. So, so according to your project, you can apply. MATLAB is also there. The machine learning packages are there in the MATLAB. Then Paddle also one other kind of the framework. So you can use the Paddle also. And because nowadays there's so much because this TensorFlow is a Google framework. Google given this framework. That's why it is so much uh, used by the many programmers. And Keras is also open source. used by many programmers. Both are Keras and TensorFlow both are combined. But this PyTorch Facebook product is performs the performance of this PyTorch is comparatively better than the TensorFlow and Keras combined, because this PyTorch model is a robust model. This framework, I mean, not model, the framework is much better than both. So it's up to you. Select that particular framework for your need. For your project, you can select. See, look at here. The TensorFlow Keras, and see this MXNet, Chainer, Pedal, all are the variant of this based on the Python. But this Cafe, Theano, TensorFlow, Keras, and PyTorch, these six frameworks are very much useful to select carefully according to your project. See, now again I'm coming back to the RPN, because this is a very core of the object detection. See, this is the model of a region proposal network. See here, the convolutional neural network and this is the image. We are going to train input. Layers are here. After that, the features are generated by these hidden layers, and another hidden layer we have to train, that is a RPN layer, that is also known as a RPN region proposal network. This layer will detect and pool, because many mathematics are here. Those mathematics taking care of the region of interest. That region of interest are pooled and then given to the dense layer, and after that the classifier is there, and that classifier classify the image. So what are there in this complete model? The COCO detection and segmentation, these two things are there. These So segmentation and detection both are the part of image processing, and this is the algorithms, COCO algorithms integrated with the detection and segmentation algorithms, so that it is a COCO detection and COCO segmentations. And then region proposal network are going to classify and detected image. It will generate the detected image and classified value. So classified value are in the numerical value, and the images are separately. So two outputs are generated. One is classifier and another is a detected image along with the regions. See how to create the environment. For the environment, the Python, you can take Python, or you can take the framework. That framework is a PyTorch, TensorFlow. It's depending upon your uh, project. And then CUDA is there. If CUDA is there, then it's good. If so, try to learn the CUDA programming. So CUDA is necessary, and you download this model. This model means if you are going to use a ResNet, then you can download that F5 model. And if you want to use the SPP net, then you can download the SPP. H5 extension you have to download and integrate with your environment. And if you want to use the TensorFlow, then you can use TensorFlow, and uh, algorithms are there. For this algorithm I use for my project. So SSD algorithm you can download and create a single environment, and after that these all framework will take care of the detection and the classifications. See, this is a complete video data. Libraries are here. Prepare extracted image, images are here. Then faster RCNN Coco Sparse. Download this. These are the frameworks downloaded, and this is a what you say RPN model. So RPN models are denoted by this set of code. I can download and change the code, and classified detection values are here. Who is a person, who is a not person, what is the bag, what other objects are there. According to that, it will generate the probability. Those probabilities are here, and then see the images and bounding box are generated separately. These values are generated separately, both, and then you can classify properly. So how it happens? The single shot detector for the multiple category. Multiple category means, see, in this image, tree is also there, bag is also there, uh, cloth is also there, hand is also there, water bottle is also there. So each and everything you have to detect. How to detect it? So SST along with YOLO, both are combined together. And then why SST? It is based on the CNN, forward approach. Means it works right from the second hidden layer to the last hidden layer. It works till then. And the bounding box and related score. See the blue color. These are the bounding box, and the related probabilities are here. These probabilities are used for the classifications. So these numerical values. So SST approach for this, this must hidden layers only, and then the bounding box scores are there, which is present in the object class, that is probabilistic value. The predict, you can say, uh, uh, object dot predicted data is equal to whether you are going to predict from the test data or the training data. So if you are going to predict on the basis of the test data, then object dot predict is equal to object dot tested data, and inside the function you have to provide that name of the class. Those class is taking care. Now those class numerical values are direct. You don't pass directly that np dot some values are there. So pass those values, and that values will take care to predict the information of the bounding box. So fixed size collection bounding box, and multiple output layers. See, why multiple? Because see the numerical value. This numerical value. This numerical value are generated by one layer. Another layer will take care to generate the bounding box. So that it is a multiple bounding box are sorry, multiple layers are required to generate the different output. If you analyze, you are going to analyze the language, then another layer is required to put to generate the uh, ana- analysis of the uh, speech, because that speech are generated by the person which is uh, uh, generated by the person in the video. So those speech, those word, you have to analyze by another output layer. That's why here the multiple output layers at the different resolution is better. See, one layer is generate the numerical value, another layer generates the this image, another layer is generate the speech. If you are, and so by this way, for different purpose, you have to use the different output layers to generate a different output. And SST architectures combined with the Coco net RCNN, all three are combined in the single environment, and it uh, compare the accuracies. Next, this SSD. SSD is very important here. Along with this, if SSD is not there, then it's difficult to generate this numerical data, numerical classification, probabilistic data. So SSD is very much important for per frame, almost 5 times more than faster RCNN. It generates fast the bounding box. The speed this bounding box are generated, the same speed the numerical value are displayed here with respect to the detection classification value is here. And that classification is probabilistic. Actually, I wrote all this. Even I generated this. I downloaded this data set. This is some video I downloaded, which is available on the internet. And this is a bus stand. Will generate the different colors. The people are in the queue, and the person is ready to. They are in standing, and the person is moving. This is another color. He is ready to for ready for the bus. He's going inside the bus. So bus is also one kind of the object, and what is the probability? That probability is showing here. So by this way, you can detect the different object using the SST algorithm. This algorithm, this I used for my one of my project. So by this way, easily you can use. And this is the model, SST model. This complete SST model. You can apply in the convolutional neural network, and you get the result. If anyone wants, then I'll give this complete project. I'll share this project to you. See, that's it. Thank you. If any question is there, then you can ask. Hello. Hello. Hello.
I request you, the participants, if you have any questions, please ask the question to our speaker.
Any kind of the question related to detection or deep learning models, classifications, hidden layers.
Right. I suppose there are no questions from the audience. I take this opportunity to thank our speaker, Mr. Saurabh sir. Thank you very much
Thank you,
for
sir.
joining us, sharing your knowledge with our participants. Thank you very
Thank
much,
you,
sir.
sir. Thanks, sir. Thanks. Thanks.
Thank you, sir.
Thanks.
Dear
Thanks.
participants, up next we have our speaker, Mr. Abrar Syed. Mr. Abrar is a visionary tech entrepreneur and software engineer with achievements in artificial intelligence and engineering leadership, renowned for leading high-performance teams, driven innovation, and delivering advanced AI solutions. He is an expert in managing software infrastructure, cloud services, technology training, with a track record of enhancing operational efficiency and business growth. Currently, he is head of platform engineering at Dublin, Singapore. Prior to that, he was VP of engineering at Noodle Factory. He has several certifications in Kubernetes, Jetkin, Docker, and Apache Cassandra, and etc. He is winner of Geeks List Hack for Good Hackathon at Red Hat Bangalore, and he is also winner of CMR Leadership Award. Mr. Abrar, thank you very much for joining here today. We welcome you. Over to you, sir.
Yeah. Thank you, Manoj sir. Thank you so much. It's an honor to connect back with the faculty. Uh, I see Swati ma'am is also here. Um, Hello everyone. So I'll be doing a 1 hour session, starting with a quick introduction of myself, followed by a quick overview of all the case studies that I've done, and maybe if you can gain some learnings from it, as well as giving you an overview of Gen AI landscape. But that said, before I start, I just wanted to understand. I mean, I believe that this faculty development program has been happening from 2 days prior to this, from Monday, right? If I'm not wrong. Hello.
Yes, sir,
Yes,
Brad.
it
From Monday it
is.
is
Yes,
happening.
yes,
All
from
right.
Monday
Okay.
it is happening.
Right. So I'm sure there would have been a lot of sessions. What I want to do is in this 1 hour, I want to make it a little more, interactive. Because I believe that, if I just do a 1 hour session, honestly, I've been a corporate trainer myself, and AI is such a deep learning curve. I don't think so I'll be able to do justice in terms of covering up everything that is there in the entire oceans of AI and ML. But what I want to rather do is, before I start, want to ensure if you have any questions or any doubts, because you've been attending two days of session, right? I'm sure you would have a lot of questions in your head. So is there anything that you want me to cover as part of my talk? So I will make sure I modify my talk to ensure those aspects are covered. Anything in particular, and feel free, you can ask any question that you have in mind, because I come purely from, not from the research or the uh, educative part of AI. I actually come from the AI, applied AI sector, which means all this AI, that innovations that are happening, I'm actually using it real time in production to actually build softwares that are being used by people in production, that are live right now, has at least thousands and millions of users, and I've built those kind of applications. So what I want to understand is, what are the questions that you guys have? If there are no questions, then I'll proceed with the plan that I have in mind. Otherwise, I'll alter my talk depending, to ensure that all your questions are addressed. Over to you guys. Any questions that you have, feel free to ask me.
Yes, sir. Good morning, sir.
Yeah. Good
Yeah,
morning.
yeah. Nice to meet you. Nice
Yeah.
introduction, sir. Can you put some light on speech signal processing area, like audio processing? What you have with respect to the AI, how the development happening? What are the new techniques?
Sure. So you want to put some highlights on audio processing, right?
Yes, sir. Yes, sir.
Okay. So that is noted. So one is, I will make sure I talk about audio processing. Anything else that you want to talk about? Anything else that you want me to include? Any questions? It could be as simple as, what are the good learning resources to get started, because the landscape is so huge, or I am planning to build so and so project. How, what part of what models can I use? Anything. So one is, I've made a note of audio processing. I'll just give maybe 1 more minute. If there are no questions, then I'll proceed with the talk that I plan to give. Okay, I think I'll proceed then. In terms of what I plan to do, I'll quickly share my screen to give you a brief introduction of what I am up to, and as well, start today's talk. So, starting with, I've currently started a new firm wherein I provide AI services to clients across the world. I currently have clients from India, Singapore, and UK, and I've been providing a lot of AI services to them. So what I'll do is I'll give you a brief overview of all the case studies that I've used in the past where we have used AI or ML or applied AI or ML, and maybe that will give you insights on how to go about building real world applications. A quick intro before we start. I think Manoj sir has already given a quick intro, but here is a small intro of myself. I'm currently the CEO and founder of company called as Sudosu, but alongside I'm also head of engineering platform for a company called as Dobin, which is a fintech company from Singapore. Previously, I have also worked as VP of engineering for a company called as Noodle Factory, wherein we were building chatbots. And this company has got at least 10 plus B2B awards, as well as raised quite a lot of funding. Um, I was also the founding engineer at Napti, and I'm also a corporate trainer for Fortune 500 companies. I have trained engineers from JP Morgan, Standard Chartered Bank, and many other companies like those. So that's a brief introduction of me. Before we start with, all the case studies, I want to kind of quickly break down in terms of how I segregate all these AI services. So basically, I segregate them into 6 to 7 sectors. Okay. So one is AI strategy and workforce development. What we do here is basically we see. So one thing I think many people underestimate or uh, don't realize is software development is very different from AI development. When you're building a software product, things are very clear in your head. For example, if I ask you to build an Uber app, or if I ask you to build an Ola app, you kind of know what is going to come before you. Like, the feature set is quite clear. You know what kind of screens you can possibly build. You can estimate the time to build those. Of course, there will be some fluctuations, but you can kind of approximately be quite right about it. But what happens when we build an AI application is it's quite different. And this has happened to me, and I can talk more about it in real world when I have built applications. Basically, when you're building an AI application, you're kind of adding AI to your product. Now, the moment you say you're adding an AI model to your product, AI model is like a wild dog. So, you need to actually chain it. When I say chain it, you need to put it into a certain controlled environment so that it performs exactly like how you want it to perform. Otherwise, the customer experience can be, extremely devastating. That is why it becomes very important to understand what the model can do, what it can't do. And because of this, the life cycle is very unpredictable. You cannot decide a timeline for it, because let's say you start with a project. I'll give you an example of this. So let's go with case studies. I was building, one of the case studies that I was working on is AI powered learning assistant. uh, when I was working on this project, we had to build a model, which is like a chatbot interface for an edutech platform. Now, what was happening here is, when we were working on this, the models we chose, they were obviously not 100% efficient. Now, there is a certain time that it takes to optimize that model. You need to come up with a feedback cycle and all of that. Now, we don't even know if this model is correct. And to be honest, the Gen AI or the AI space is evolving so fast, and this has happened to us. We took almost a year to, fine tune a certain model, only to realize that 2 years later, there is a completely better model altogether. And all that 1 year of efforts have gone down the drain. So one of the things that we do as part of services is come up with an AI strategy for companies, wherein we help them decide whether even building a model on your own is a good decision or not, and why it is not a good decision. And we back this up with actual data. So this is the first step. Second is, sometimes what happens is, when we work with companies, obviously, they don't look at always depending on external agencies like us to build their core products. So they would want their in-house team also to be at par and upskilled along the process. So what we do is we also provide workforce development, wherein along with the strategy we also come up with plans training programs such that, by the end of a certain service development or product development, we also ensure that the in-house team is also upskilled on it and they have the right skills to take that forward. So that is one of the things that we do. Second service that we work on, and why I'm talking about these services is not because I'm kind of marketing pseudo here. What I'm trying to tell you over here is more on the lines of trying to give you a gist of all the things that are happening in the real world right now. So these are some of the things, and you can go on any one specific thing and focus on that deeply. Second is data science. So data science and predictive analysis. So what we do here is, again, there are two parts to this. Even, sometimes companies like BCG, Cargill, all these big companies, even before you get into the step of data science, you need to first get data engineering and data analytics sorted out. And what is the difference here? Basically, data engineering is ability for you to, extract the essential data from different resources, come up with a pipeline to, filter the data, clean the data, and put it in the right form. So that is basically the data engineering part. And then comes the analysis part. So sometimes what happens is, not every time you're looking for, a model or an outcome. Sometimes you're just looking for gaining some insights on the data. So that is where, we offer a second type of services, which is predictive analysis. For example, during the COVID time, uh, we can do predictive analysis on what kind of how effective was the vaccinations that was done, and which vaccination was more effective in which country, things like that. And lot of these things that we can do. And that is basically where, one of the services that we offer is predictive analysis. Over here we are not exactly building a model, but what we're doing is we are trying to gain some insights on the data that is provided, and trying to, give insights on those. Here, this is not exactly AI, but it is a prereq to, actually going ahead to build a product which might be AI driven. So that's the second services that we offer. Third is AI model management and ML ops. Now, what we do here is, this is where, so, in the first step, if we decide that AI, after the AI strategy discussions, if we decide that, let's say, a company wants to go ahead and build a model. Okay, so to be honest, today there is a very important question you need to ask yourself if you're building a real world application, is if you should use an existing model or if you should build your own. And even if you're using an existing model, do you need to really fine tune it? And I'll go into more depth on what I mean by this. But essentially, once that decision is taken, what we do is, in this step, we basically help the company to design customized model for their use cases. And with this comes a lot of ML ops, wherein, you basically have to understand how to deploy it, how to manage memory in it, how to manage scalability, all these issues. So this is what is addressed in this particular services. Then comes Gen AI for marketing and content creation. Now, to be honest, I'm sure in the last 1 or 2 years, after LLMs and, OpenAI has been out, there has been a lot of buzz about Gen AI. But to be honest, there is a saying, uh, hallucination is not a bug, but a feature. Okay. And what it means by that is, right now, the models that we have, they're very generic in purpose. Like, for example, when the first version of OpenAI came into picture, a lot of researchers and professors were, thrashing it, saying that it is just garbage and all of that. And why were they telling that? Were they completely wrong? Not exactly. The reason they were saying that is because for their use cases, it was not exactly providing the right outputs. Okay. And slowly that has evolved. Slowly the models has started less hallucinating and trying to give the correct outputs. But that said, when you're working with numbers, especially I have worked in edtech and I've worked with fintech. So one of the applications that I've built in edtech is AI driven paper corrector, wherein it is able to correct medical papers. So all these medical students who write exams, we help them actually automatically correct those question papers. Now, obviously, the answers are sometimes very subjective, and sometimes it is like a quantitative answers. In those cases, we can't be hallucinating, because the moment you hallucinate in those cases, obviously, some student is losing his marks, which is not great for the product, because people will not use it then. Same with fintech. If you're using AI in fintech, your model can't be hallucinating, because the moment it is hallucinating, people will lose trust in it. But one of the best places where Gen AI is right now being used is marketing and content creation. And I'll talk more about this. And this is where, some of the things that one of the questions that you raised, right, about audio processing, some of the things that I'm actually planning to use for my own content creation process. I'll talk about this in more depth. So one of the use cases that I feel of Gen AI more than any other domain, it is mainly in marketing and content creation. So this is one of the things that Gen AI is heavily used for. Apart from this, the other services that we offer is helping you build a chatbot application or anything which is related to NLP or language models. Now, previously it was a little hard to build language models, but with RAG and LLMs out, it's much more easier. Next that we work on is intelligent workflow automation. So some bit of here is also RPA. What we do is, and this is one of the case studies that I've worked on. What we do here is, so sometimes you don't need AI to actually do all the things for you. What you're essentially looking at is eliminating your repetitive task and trying to get some sort of automation in place. And when I say some sort of automation in place, when I say that, it means that 80% of it is, probably code or software driven, and maybe there is a small intervention of human, because AI can't be as precise as human in certain decision making. So that is where we use a certain intervention of human to achieve the end goal. And this is different from AI model management and ML ops in the sense that there is a bit of human intervention involved here. And I'll talk more about this, how that still helps the process. I have case studies around all the services that I've talked about. The last one is computer vision and document processing. Again, this is related to AI, I mean VR, AR, or optical character recognition, all of these things. So this is an overview of all the services that we offer as a company, and also an overview of all the things that you can actually do with AI. Okay, so don't see this as something under pseudo, rather see this as something that you can actually do all the things that you can possibly do with AI. Any questions up to now? Any questions? All right. If no questions, I'll proceed to the next one, which is case studies. Uh, So I have about one, two, three, four, five, six case studies, and I'll walk you through all of them. And while I do that, I'll also give you insights on how I developed it, and what are the things that got involved in getting this done. So first is starting with a company cap table generation and AI success story. So basically, what was the problem statement here is, I'm sure you guys know, right? Like India is like now the hub for a lot of startups. So there was this company called as Rule Zero, and what they basically do is, let me just quickly show it to you. One minute. One second, my keyboard is not working. Okay, I think I have issue with the keyboard. Just give me one more minute. Okay, I'm really sorry. I don't know why the keyboard is not working. Anyhow, I'll try to show from the other screen. So there's this company called as Rule Zero. Basically, what they do is every time a company raises a round of funding, uh, there is a cap table that is generated. Now, what was happening is basically for one company's cap table to generate, it required at least 7 lawyers to basically sit on that data and extract the data and probably extract the data from MCA, which is Ministry of Corporate Affairs, and basically generate that one cap table. Now imagine doing it for all the companies, and this company was basically into providing a equity management platform for all the startups around India. Now it is obviously if you do one company, if one company takes 7 days, it becomes a huge problem. So what we did here is we basically helped come up with a solution wherein we build a AI solution for them, which kind of was able to, what was taking 7 days was now taking just 15 minutes of time, and it required just one lawyer's intervention for 5 minutes. So something that was taking 7 days and 7 lawyers now took only one lawyer for 15 minutes, and it was done. So this highly impacted the company's B2B sales. It almost increased their sales and lead generation by 10x. And this is something that we did, and this comes under what I told you, right? Intelligent workflow automation. So this is not exactly a completely AI automated, but it is 80% automated. Now, how we achieve this? So what we did is first is extracting information using from the MCA website. Now that is a straightforward integration. What we do is we build software systems to ensure that we can extract data periodically and process them and store it in our storage from the MCA storage using API integrations. After that, the important part was all the data that we got from MCA was actually in PDF or image formats. Now, how do we actually convert that into textual data? Because we wanted numerical data extracted out of these documents. So what we did is we used OCR techniques, and we evaluated a lot of models. The one model that worked out properly for us was ABBY, ABBYY. So that was the model that worked out for us, and we kind of fine-tuned it furthermore to actually achieve this task. So this is one of the applications of intelligent workflow automation. Next is we have next one, which is this AI powered learning assistant. So this is where I worked as VP of engineer for the company. Let me just show the okay, I'm not allowed to share screen from the other system. Uh, Manoj sir, can I get access to the other system to basically allow to share my screen? I've joined through two systems. Hello? Hello, Manoj sir? Hello.
Yeah, Abra.
Yeah. Can I get access on the other system, sir, to basically be able to share screen?
She's okay. You're fine.
Yeah. Hello.
Can you please, are you able to share what exactly is your requirement? Could you?
So actually, I've joined through two systems, sir. So the one of the systems where I'm able to share, I'm facing a keyboard issue. So that is why I'm using the other system to share my screen where I can use the keyboard. But the other system, I'm not having the share access. It's saying only meeting organizers presenters can
Acha,
share.
I understood. I understood. It will be done right away. Just give me a moment.
Okay, all right.
Yeah, Abra, you can check now.
Yeah, I can. I have the access now, sir. Thank you so much. Right. So back to the topic. So this is one of the. Can you guys see my screen? Yeah. So this is one of the chatbots that we built, and let me tell you, we built this chatbot when there was no Gen AI. So we were still not having LLMs. We still didn't have. I mean, Transformers was just launched, and it was very new for use. So this is one of the chatbots that we built, and this is in production right now. It is in Singapore, and you can see all the universities that are using it. Let me show you. So these are all the universities of Singapore who are actually using this in production. Some of them are also, corporate clients, but most of them are universities across Singapore, London, US, who are actually using this chatbot now. And this is the one that I talked about, the medical paper, right? So there are two AI products that we built for them. One was a edutech platform. So what we do is every university has a lot of data. For example, even your college, now you have a lot of subjects, you have a lot of assignments, and there is a lot of textual data. And what students want to do is, what we did is we basically provided a interface wherein you can actually upload all your data. It could be in any format. Some of them could be in PPT, some of them could be in PDF. We allow you to upload all kinds of document into a certain single storage, and then we provide a chatbot interface on top of it. So what we do is a student can come to that chatbot interface and ask any question. So if we ask any question, for example, let's say, teach me about neural network. Now it will exactly know which document to refer to, and which page number to refer to, which paragraph to refer to, and will exactly give that kind of information. So now the student can just chat with the chatbot and learn. So this is one of the products that we built for them. And once they have done a considerable amount of chatting, we also ask them if they want to take up some tests or assignments. So now the whole process of learning is more interactive, it's more fun, and it's more engaging. And it also reduces a lot of efforts of the teachers and professors to actually not actually sit and do all the manually correction of all the assignments and evaluation of all the exam papers and all of that. So this is one of the things that we did. And We did this before LLM and transformers were into picture. And what happened was we even collaborated with AI Singapore, which is one of the departments under NUS, National University of Singapore, and it is also backed by Microsoft. So we worked closely with them to improve our model. So initially our model's accuracy was 67%. We brought it down, we brought it up to almost 78%, only to realize that the LLMs and uh, transformers that are coming out today are much more efficient than what we did back then. So this was one of the learnings on making sure when to use AI model, when not to use an AI model. So these are some of the things that we did. uh, Another case study is okay. One of the other case studies is a medical powered precision. What we did here is, and this was a very simple, this I think was the most simplest project. So what we did here is, I'm sure you guys go to hospitals and clinics, right? And what happens there is a doctor writes you a certain prescription, which is, a problematic for you to understand because of the handwriting. So what we did is, the moment a patient or a doctor actually talk to each other, we basically, convert audio to text using good AI models. And then what we do is we kind of detect on those textual data. For example, if a doctor says that you need to take crocin 5 times a day before breakfast, what we do is we basically analyze this statement and we understand what is the name of the medicine, what is the frequency, which is 5 times a day, I mean five times a week, and what is the dosage, which is morning, before food or after food. And we kind of put that down into a table, and we send this to the patient's account, email account. So now what happens is, the doctor doesn't need to write the medical prescription. The patient doesn't need to actually worry about handwriting issues and taking the wrong medicine. All this is done digitally, and this can later even be used furthermore by companies like people who are in the medical sector to automatically deliver the medicines to the patients if he approves it. So this is one of the things that we did, and this also resulted in the paper in the company going forward to securing a patentship on this particular approach that we took to solving the problem. So these are some of the important case studies that we worked on. Now, something more on the Gen AI world. So one of the things that I want to talk about is I have also started a YouTube and Instagram content channel, and I'll tell you what is the reason for it. See, normally when you're building a software product, what happens is distribution becomes a very important thing. Because to be honest, when you're working in the real software world, every other day people are producing software. There are so many softwares which are very good, but people don't even know about it because they don't have a distribution for it. So for example, when you say Slack became popular because it had a good distribution. The products that you use today, WhatsApp, Facebook, Instagram, all this became popular because they had a good distribution. There are so many apps like Instagram which people never even got to know because it never got the right distribution. So whenever you're building a whenever you're building a software product, it becomes important to ensure that you also have a distribution channel. Now, how do you get a distribution channel? One of the ways is you actually go about doing SEO, you do digital marketing and all of that. The new way, especially after Gen AI came into picture, people have started using content creation. Becoming an influencer or becoming a YouTuber has become the new trend now to actually become set that as a distribution channel. Because the belief is that if you keep providing valuable services to the public for free, over time they will build a trust for you. And now when you pitch a certain product, the likelihood of people believing on that product is much easier. And this is true since the ancient times. If you see only the TV stars and the cricketers were actually used for endorsing certain brands. And why was this happening? Obviously, because, people trust those TV actors and, cricketers. So now this has become commoditized. People are now trying to become the next face of YouTubers and influencers. Now, when I say that, how do we automate that? So one of the things that I'm looking at is, I'll give you an example of this. Have a look at this channel. Okay, just give me a minute. Can you guys still see my screen? So let's take this channel for an example. And this is just an example of, what we are trying to do. So for example, look at this video. Okay. Uh, so did you guys see that video? Hello. Okay, so here's a question for you guys. Okay, I see no. What was the issue? You were not able to see the video? Hello? Screen is not visible. Are you guys not able to see my screen? Let me share it again. Can you guys see my screen? Hello? Guys, please interact. Are you guys able to see my screen? You're still not able to see my screen? Let me disconnect from the other one so that I am only connected on one device now. Are you able to see my screen now? Hello?
Yes, we are able.
Okay, I think this should have been highlighted before when I was talking, because there's a lot of things I showed here, but I think it all got missed out. Were you able to see when I spoke about all this? Okay, all right. So I'll just show you the video again. Please tell me if you can see the video.
This video, I think they've seen. They're able to see.
You're able to see the video, right?
Yes.
Okay, all right. Should I replay it or is it already seen? Hello? Yeah, was the video already seen or should I replay it?
I think they've seen already.
Okay. So here's the question for you. The person you see in that video, the orator of the video, do you think he's an actual person? So the answer to that is no, it's not an actual person. It's actually an avatar. And this is what I've been trying to achieve with our channel as well. So we have started a pseudo. Let me just share my screen. Right now, if you see, I've started a new channel wherein we post, shorts. And right now, if you see, these are real avatars of me talking about, AI. But slowly, what I plan to do is I want to use a technology like HeyGen, for example. And what HeyGen actually does is it can actually generate an AI avatar of yours. So for example, let me show you. So look at this. Let it load. Yeah. So what you can essentially do is you can just give a script to it and it will start talking like this. So this is actually the founder of HeyGen, and he's using a script and there's an AI avatar generated like this. And already this is being used by a lot of TV channels to actually have news anchors. So the news anchors that you see are no more, real people who are doing it. These are actually AI avatars who will be replacing the real humans to actually converse like this. And the same thing is happening in sales. So when you talked about, I think one of the questions that was raised, right, about audio processing innovations that are happening, one of the innovations that is happening in audio processing is this. So what there is another company called as 11 Labs, and I think the one who asked this question should check this out. So what this does is it basically it's a AI voice generator, and it helps you to generate a similar voice to how you have your own voice. So you can actually use this software to train the AI model to understand your voice. And now you can generate videos like this. So a combination of HeyGen and 11 Labs can actually help you achieve automation on content creation without actually, being without actually sitting in front of a camera and shooting everything. Now imagine this is just the beginning. Imagine the kind of innovations this can do into the entertainment industry. I already gave you an example of, channels. Some of the channels like Times of India and other channels are already using this for their as their TV anchor. So you no more have TV reporters as humans. So these are some of the things that are happening. Uh, so that's a very brief view of the entire landscape. There is so much more to talk about AI on a daily basis. And that is one of the reasons that I've started a YouTube as well as an Instagram channel. So if you guys want, please do subscribe to Sudosu AI. You can even go check it out on Instagram. And this is where I kind of, on a daily basis, share all the innovations that are happening around AI. And I share it completely from the perspective of, applied AI, wherein what all researches are happening, what all models are actually being put in production, what all applications are being built, what is the underlying technology behind all the innovations that we're talking about. So please do follow Sudosu AI on Instagram and YouTube uh, if you want to follow up on more AI content. Uh, that said, I leave the last 10 minutes to any questions that you guys have or anything that you want me to answer in specifically. Any questions? I think if there are no questions, then I think we can end the session. Thank you so much, everyone, for your time. And feel free to connect
Thanks.
in case you have any questions. In case you're building anything or you want any specific doubts, feel free to reach out to me. Uh, More than happy to connect with you. You can probably take my contact from Manoj sir, and we can
Yeah, good afternoon, everyone. This is Manoj here. Any questions? We can have one or two, if anything.
all right.
Okay.
Thank
First of all, I would like to thank Abrar for accepting the request and spending 1 hour time and sharing his experience. So thank you very much, Abrar, for for accepting and
Sure, sir.
sharing your thoughts. Okay.
Sure, sir.
And yeah, so thank you. That's why I came just to thank you, especially so for
No
accepting the
problem, sir.
things.
Thank you so much.
Yeah.
Actually, I think
Okay.
1 hour is a little too small to actually encapsulate everything.
Yes,
That's
yes.
kind of given like a very overview so that it kind of helps them to understand all the things that are happening in the real world with AI. Of course, I could
Okay.
have gone into more depth on what model am I using and all of that, but I didn't want to make it, boring because it's a 1 hour
Okay.
thing.
Okay.
So that's the
No,
only reason I
definitely
didn't get.
one session we can plan offline. You can come to the campus based on your availability. We can plan it.
Sure, sir. Sure. Definitely. All right.
Thank you,
Thank
Arbor. Thank you very much once again. I'll call you. I'll call you personally.
No problem. Thank you, sir.
Thank you. Thank you. And we'll end the session today and we'll start tomorrow with the day 4 session.
One small
Abrar,
thing, is
yes.
it possible to take a quick photo if possible?
Pardon?
Is it possible to take a quick photo? Like a
Yes,
screenshot
yes,
or
yes. Yeah. Anyway, we are taking some screenshots.
Okay. So I think
Yeah. Screenshot and
share-
video I'll be sharing with you.
Sure.
Sure.
Thank you, sir.
Yeah. Okay. Thank you. Thank you very much. Thank you. Thank you all for joining for today. Tomorrow we'll meet at 10 o'clock. Thank you.
Thank you.